Hi, in this video, we are going to discuss exponential function, equation, and inequality. And if you want to download this PowerPoint presentation, just go to my website. It is written there. And for our recall, let us have the laws of exponents. Say we have two real numbers, positive real numbers, which is not equal to or which are not equal to 1. Say this x and y are real numbers. And if we have this number 1, a raised to x multiplied by a raised to y, we're just going to add the exponent and copy the base. We have here 2 squared multiplied by 2 cubed. We can say that it is just equal to 2 raised to 5. We're just going to add the exponent and copy the base. And evaluating 2 raised to 5 is 32. Second one is a raised to x raised to y. So the exponential expression is raised to another exponent. If we have that kind of expression, we can also rewrite it as a raised to xy, or we're just going to multiply the exponent. For example, we have 2 cubed raised to 2. We can say that it is just equal to 2 raised to 6 or 64. And if we have this product of a and b raised to x, we can just distribute the x on a and b. Okay, take note that the operation here is multiplication. It is not addition nor subtraction. If that is the case, we cannot apply distribution or this law of exponent. No. So for example, we have 2 times 3 raised to 2. Okay, 2 times 3 raised to 2 can be written as 2 squared multiplied by 3 squared. And if we're going to evaluate that, that will be 4 multiplied by 9 or 36. And it is just similar to number 3. The only difference is the operation here is division. A over b raised to x is just equal to a raised to x over b raised to x. Or simply, if we're going to, or to give an example rather, 1 over 5 raised to 2, it is just equal to 1 squared or 1 all over 5 squared, which is 25. And for our fifth example, or fifth law, we have a raised to x all over a raised to y. We're just going to divide exponential expression with the same base. If this is the case, we're just going to subtract the exponent. To give an example, we have 2 raised to 5 all over 2 raised to 3. And subtracting 3 to 5, we have here 2 squared or 4. Okay, so for our first definition, we have this exponential function f with base a. It is denoted by f of x equals a raised to x. Take note that a is a positive real number that is not equal to 1. Okay, and x can be any real number. It can be positive, negative, or 0. The exponent can be positive, negative, or 0, but the base should be a positive real number not equal to 1. So the properties of exponential function f of x equals a raised to x. The first property tells us that the domain of f is the set of all real numbers. The range of f is the set of all positive real numbers. Is 0 included? No, because 0 has or is neither positive nor negative. Okay, the y-intercept is at point 0, 1, because if we set x to 0, y will be equal to 1. So we have the y-intercept is at point 0, 1. F of 1 is equal to a, meaning to say, if we replace x by 1, it will just be equal to a, or the base. For our fifth one, tells us that if the base is greater than 0 but less than 1, as the value of x increases, the value of y decreases. And if a is greater than 1, as the value of x increases, the value of y also increases. Now, the seventh property tells us that f is a one-to-one function. Meaning to say, if f is a one-to-one function, if we have here a raised to x equals a raised to y, we can just say that x is equal to y. Okay? Or vice versa. If x is equal to y, a raised to x is just equal to a raised to y. It seems to be we just cancel the base. But we cannot say we cancel the base. We can say that we just use the property of exponential function. And for the last one, the graph of f has a horizontal asymptote y equals 0 or the x-axis. Now, this one is helpful if you want to uh, solve exponential equation and exponential inequality. Take a look at this. You may take a screenshot of this, and you can use these values to solve on the later part of our discussion. Now, to give you the first example, we have 5 raised to 2x plus 1 equals 25. Now, that is the given. Using prime factorization, 25 can be written as 5 squared. So I just replace 25 by 5 squared. And after that, we have to use the seventh property of exponential function. If we're going to use the exponential property, or yes, property of exponential function, since they have the same base, we can just equate the exponent. 2x plus 1 equals 2. And by addition property of equality and multiplication property of equality, subtract both sides by 1 and divide both sides by 2, we can deduce that x is equal to 1/2.
So for our second example, we have 2 raised to 3x equals 16 raised to 1 minus x. Okay, it is the given. So I write the given, and after that, we have here, it tells us that we are going to use prime factorization. And the prime factor of 16 is 2 raised to 4. So I just replace 16 by 2 raised to 4. And then by the laws of exponent, okay, 2 raised to 4 raised to 1 minus x. Since um, we can apply the laws of exponent, in other words, we're going to multiply 4 to 1 minus x. Doing so, we have 4 minus 4x. 4 was distributed to 1 and negative x. So for the next step will be, or since they have the same base, using the property of exponential function, we can say that 3x equals 4 minus 4x. Okay? It seems to be, you just cancel the base. But we cannot say we cancel the base. We can just say that we use the property of exponential function. And by algebraic manipulation, and that is addition property of equality and multiplication property of equality, x is 4 over 7. Okay, so for example number 3, we have this exponential inequality. We have to solve 2 raised to x plus 1 is greater than 32. Take note that 32 can be written as 2 raised to 5. So we have here 2 raised to x plus 1 is greater than 2 raised to 5. And since they have the same base, so they have 2 as their base, we can just uh, use the inequality to the exponent. It seems to be ano naman, no, rational naman, since they have the same base. The exponent of, or the exponent x plus 1 should be greater than 5. Okay? So we equate x plus 1 is greater than 5. Or we just claim that x plus 1 is greater than 5. And then divide or subtract both sides by 1. We have here x is greater than 4. Okay? Or we can rewrite it as 4 exclusive up to positive infinity. And we can graph it as this. As you can see, 4 is hollowed. It means 4 is not included in the solution because it is greater than, x is greater than. 4 is not greater than 4. Therefore, we will not include 4 in our solution. Anything greater than 4 is included.
So for our fourth example, we have 4 raised to 3x plus 2 is less than or equal to 64. Okay, take note that 4 can be expressed as 2 squared and 64 can be expressed as 2 raised to 6. And using the laws of exponent, 2 will be multiplied to 3x plus 2. Doing so, we have 2 raised to 6x plus 4. Now, since they have the same base, um, we can just apply the inequality to the exponents. No? Doing so, we have 6x plus 4 is less than or equal to 6. And divide both, or by using algebraic manipulation such as subtract both sides by 4 and divide both sides by 6, we can arrive at x is less than or equal to 1/3, or from negative infinity up to 1/3 inclusive. Sir, why is it inclusive? Because there is a equal symbol, okay, in um, as their relationship, no? It has an equal sign. So 1/3 is part of the solution. Okay, another solution or an alternate solution is we just replace 64 by 4 raised to 3 because 64 is also equal to 4 raised to 3. If we do so, they already have the same base, so we can just apply the inequality to the exponents. Doing so, we have 3x plus 2 is less than or equal to 3. Subtract both sides by 2 and then divide both sides by 3. We arrive at the same results. So, uh, whether you use the left one or the right one, it really doesn't matter because you will still arrive at the same result. Now, if you find this video helpful, you may click the like button, and if you're new to this channel, hit the notification bell as well as the subscribe button so that you will be updated to our next video.